Okay, sekejap Ada kelas ke tadi?
Tak.
Tak ada.
Tak ada.
Oh, bangun tidur lah ni. Sekejap ya. Baiklah, semua dah ready ke ni?
Dah.
Ke bantal masih di kepala? Kan? Kau tahu kan tak nampak? Okay. Okay, so hopefully you focus lah ya. Tak kisahlah bantal kat kepala ke, yang penting you kena dengar. Kan? Sebab you dah besar dah. Okay. Saya malah nak suruh on video. Bila on video penggunaan data lagi kuat sebenarnya. Okay, so kita start hari ni. Okay, osmoregulation of human. Okay, so the word osmoregulation, okay, osmoregulation ni under homeostasis. Why under homeostasis? Because osmoregulation itself maksud dia proses, okay, proses maintaining salt, okay, gula pula, garam, okay, salt and water, okay, kan, osmosis, you dah biasa dengar kan osmosis kan, so mesti involve water and also salt, sodium kan, potassium, yang tu semua akan regulate water kan, okay, so that's why regulate kawal atur, so we want to regulate salt and water, and some textbook dia guna perkataan electrolyte, okay, electrolyte and water. Okay, so in this subtopic, okay, first you will learn about kidney structure, sebab kidney involved with all the process, okay, and then formation of urine, and last kali hormone involved, okay, which is ADH and aldosterone. So ada 3 sahaja, okay. Now, okay, this is introduction about kidney, okay, and kidney, okay, dekat sini, kidney function in both excretion and osmoregulation. Excretion to process is a process of eliminating or expelling waste from your body. Okay, you nak eliminate apa yang you tak perlukan. For example, you don't need nitrogenous waste in your body because nitrogenous waste ni tend to form toxic ammonia. So it's not good for your body. So you need to excrete nitrogenous waste. Kalau tidak dia jadi ammonia and dia akan meningkatkan you punya pH you dalam badan kan. So we need to eliminate. And then apa lagi? Okay, kita nak control solid concentration and balance water gain and loss. Tadi saya dah mention osmoregulation. We want to maintain salt and water. Okay, nampak sekarang sini dia guna solute, sometimes dia guna salt, sometimes dia guna electrolyte. Okay, now the 2 distinct regions of kidney, I'm sure you dah pernah dengar ni, cortex and medulla. Okay, cortex bahagian outside dia. Okay, outside, medulla middle, so dia bahagian middle dia. Okay, okay, renal cortex and medulla are the nephrons actually. Okay, bahagian nephron function units of the vertebrate kidney. Okay, nephron ni adalah functional unit, okay, of the vertebrate kidney. So yang ni you tak perlu hafal ayat-ayat ni, yang penting you tahu yang ni okay. Bahagian utama renal cortex and medulla, and then nephron as the functional unit. Ini you tahu. And then apa function kidney? To regulate, okay? To regulate solute concentration or salt concentration and balance water gain and loss. Okay, so yang ni tengok gambar terus dah kot. Okay, I'm sure you dah kenal dah, okay, renal cortex, okay, bahagian outside dia, and then renal medulla, middle, okay, middle. So, jangan buat mistake benda-benda macam ni, make sure you kenal structure dia, and of course, setiap organ is supplied with blood. So, we have renal artery, okay, and also we have renal vein dekat sini, and renal pelvis ni dia akan receive urine from collecting duct, okay, and dia akan channel to ureter, okay. So this is the main structure of kidney, and okay, kita tengok nephron pula. Okay, nephron is the functional unit of kidney. We have 2 types of nephron. First, juxtamedullary nephron, okay. Second is cortical nephron. Juxtamedullary nephron, nama dia juxtamedullary because if you see here, okay, dia extend out. Nampak tak ni? Dia extend out. Okay, sampai bahagian renal medulla ni. That's why we call this nephron as juxtamedullary nephron. And the other nephron, cortical nephron, sebab dia ada bahagian cortex. Okay, bahagian cortex sahaja. Okay, you dah nampak dekat sini cortex area. Okay, so kita panggil dia cortical nephron. Okay. Okay, so yang ni main structure lah. So kalau you tengok dekat sini, ni semua explanation dia lah. Renal cortex, the outer part of kidney has a smooth texture. Location is the location of the Bowman's capsule and the glomerulus. Ni sangat penting lah. Okay, ni maksudnya glomerulus and Bowman capsule is located at renal cortex region. Okay, and ada lagi bahagian-bahagian lain. We have proximal and distal tubule. Nanti kita tengok okay, kat mana proximal? Okay, kat sini you nampak tak? Proximal convoluted tubule. Okay, proximal. Okay, kenapa nama dia proximal convoluted tubule? Sebab dia very proximate. Proximate mean close, dekat dengan glomerulus. Okay, so kalau kelas nanti sekolah keluar structured question, kalau ada label kat sini, you nak identify whether it is proximal convoluted tubule or lagi satu distal tubule. Tak ada kat sini. Nampak distal tubule. This one, distal tubule. Okay, distal tubule or proximal convoluted tubule. You tengok adakah dia berhampiran dengan glomerulus. Okay, so yang berhampiran dengan glomerulus ni kita panggil dia proximal convoluted tubule. Proximate, dekat. Kalau distal ni dia jauh sikit, distance, ada distance sikit. So kita panggil dia distal convoluted tubule. Okay, ni bahagian yang you kena tahu. Wajib tahu sebab dalam exam kita tak tahu, mungkin dia akan tunjuk structure A dan dia tanya function. Boleh juga jadi macam tu. Okay. And okay, kita tengok ke sini. So proximal convoluted and distal tubule also located in the renal cortex region. Okay, and renal medulla is the inner part of the kidney, bahagian dalam tadi kan medulla, and the renal pelvis. Okay, renal pelvis yang macam funnel shape tadi. Okay, yang ni renal pelvis. Okay, nampak kan? So dia akan receive dia akan receive urine. Okay, from collecting duct. Okay, ingat collecting duct and papillary duct. Saya ada tak gambar lain. Okay, this is renal pelvis. Okay, and dia akan channelkan kepada papillary duct. Ni ada papillary duct dekat sini. Okay, papillary duct. After collecting duct, we have another duct, papillary duct. Tapi tak glamour sangat lah. Selalu kita akan cakap from collecting duct je lah in general. Okay, so dia akan terima urine from collecting duct to renal pelvis and ureter. Okay, so ada gambar yang you tak ada ya, saya letak sebagai tambahan untuk bantu saya explain. Okay, now of course semua orang dah tahu we have two kidneys. Okay, water balance and salt regulation. Okay, no need to memorize because you already know. Okay, ni saya dah mention is supplied with blood. Okay, kidney is supplied by blood. Okay, we have renal artery and renal vein that supply blood. And then ureter, you dah familiar kan? Starting from collecting duct, dia akan pergi dekat renal pelvis and ureter, and then dia akan pergi dekat urinary bladder, and last one is urethra, and dia akan expel. Okay, so you kena tahulah dia punya ni apa dia? Pathway dia. Okay, so you buat macam tu lah. So starting from apa? Kat sini collecting duct. Okay, so next apa dia? So you kena buat lah dia punya pathway dia. Okay, this one. So I'm sure you dah tahu dah buat lab. Okay, semua ni. Cuma sayang kan best you tak masuk lab. Okay, so bila you tak masuk lab, okay, because last experiment normally kita akan buat mouse dissection. Okay, so I'm sure you dah pernah buat during secondary school, but at this level, okay, dia lagi detail. You akan tengok adrenal gland. Okay, when you do dissection bukan simply main saja. You akan observe where is adrenal gland, dekat mana ovary. You akan nampak ovary kalau tikus tu betina. And then you boleh nampak dia punya this one renal artery. Okay, and renal vein you boleh nampak, and you boleh tengok semualah. So sayang sikit lah your batch, tapi tak apalah, you tengok je lah dekat sini kan. Nanti ambil medik you tengok lah yang actual punya, your human punya. Okay, so yang ni you boleh nampak dia punya flow dia. Okay, you have here your this is tak ada. Okay, you kena tengok semua ni apa, ureter, okay, ureter, urinary bladder, and the last one is urethra. Okay. Now nephron, you dah biasa kan dengan structure nephron kelas sekolah menengah belajar tak? Nephron structure?
Belajar.
So I'm sure you are familiar dah. Okay, so Bowman capsule, we have glomerulus, proximal convoluted tubule, loop of Henle, and distal convoluted tubule. Ini semua structure yang wajib you tahu. Okay, glomerulus, apa job dia? Bowman capsule, proximal convoluted tubule, loop of Henle, apa function dia? So dekat sini dia ada tulis dekat sini. Glomerulus filters blood. Filtration, they involve with filtration. Kalau Bowman capsule, it surrounds glomerulus and receive filtrate from the glomerulus. Maksudnya glomerulus akan filter, okay, and dia akan it will be received by Bowman capsule, okay, and later on dia akan pergi to proximal convoluted, lobe of Henle, distal convoluted tubule, and last kali collecting duct. Okay, so dekat sini structure wajib. Okay, nampak tak ni proximal tubule class? Very close to glomerulus dekat sini. Okay, glomerulus is a ball of capillaries. Okay, it's a ball of capillaries. And kalau you tengok dekat ni warna kuning ni, nampak tak semua kuning ni? This is nephron structure. Okay, ni semua nephron structure. And take note dekat sini, nampak tak ni blood capillaries? Dekat sini. Kita panggil dia peritubular capillaries. Okay. So, your nephron is surrounded by peritubular capillaries. Ni banyak peritubular capillaries. Kenapa dia very close contact with peritubular capillaries ni? Okay. Because you kena faham function nephron sendiri. Sebab dia nak dia akan receive whatever toxin from your capillaries. Dia akan masuk dalam ni. And at the same time, dia akan reabsorb. Okay, reabsorb whatever yang important solute. For example, macam vitamins, vitamin D ke, minerals ke, sodium, potassium, amino acid, glucose, whatever important things yang dia nak conserve water ke, dia akan masuk balik dalam blood capillaries ni. Okay, so that's why your nephron is very close contact with these capillaries. Okay, so senang, you nak excrete or secrete. Okay, nak absorb balik ke kan? For example, kalau not enough water, dia akan masuk balik dalam blood capillaries ni. Okay, so nanti kita akan belajar lah in detail apa yang menjadi dekat sini. Okay, cuma kat sini saya nak you fahamkan structure dia. It is surrounded by blood capillaries. Okay. And this is ball of capillaries, bergumpal-gumpal dekat sini, surrounded by Bowman capsule. And we have afferent arteriole and efferent arteriole. Afferent arteriole, bila darah masuk, okay, dan darah akan masuk through afferent arteriole and keluar melalui efferent arteriole. Okay, if you can imagine class, okay, your heart pump blood, betul? Your heart pump blood. Okay, your heart pump blood and pergi dekat mana kelas? Dia akan pergi dekat artery. Okay, after artery, arterioles. Okay, arterioles. After arterioles, dia akan pergi dekat capillaries. Dekat capillaries ni unik sebab capillaries ni one cell thick. So dekat capillaries ni akan berlakunya pertukaran. Okay, diffusion, nutrient dia nak hantar dekat badan ke body cell semua melalui capillaries actually. Okay, and then after capillaries dia pergi pula kepada venules. Okay, venules, vein, kan, veins and back to heart. pump lagi kan. So kalau you tengok dekat sini, afferent arteriole, maksudnya dia receive blood from artery. Kalau saya tanya artery jenis apa? Renal artery. Okay, yang lebih spesifik, renal artery. Heart pump blood to renal artery and dia akan masuk through afferent arteriole. Okay, akan masuk and keluar melalui efferent arteriole. Faham Okay.
Faham.
Okay, nampak ni? Ni from renal artery, darah masuk. Okay. Ni to renal vein, maksudnya deoxygenated blood, dah warna biru dah dekat situ. Okay, deoxygenated blood. Okay, what else yang kita ada? Loop of Henle, I'm sure you dah familiar, loop of Henle and collecting duct. Okay, let's say lah lepas ni, after this kan, you badan you dehydrated, less water. Hari ni tak minum air. So, apa berlaku? Dekat sini akan lagi banyak water will be reabsorbed. Okay, reabsorb dia kena masuk ke, dia keluar. Dia kena keluar. Masuk keluar bukan dia keluar. Maksudnya, dia akan reabsorb by our capillaries dekat sini untuk conserve water. Okay, kalau banyak sangat then dia akan keluar ikut sini, collecting duct. Okay, because you have more urine. Okay, padahal you tak perlu, you have more water in your body, so no need. Okay, no need to conserve. So you akan buang lah. So dia akan become urine. Okay, so this is nephron. Now kita tengok, so nephron is organized to process blood filtrate. Okay, so ni main job. Okay, formation of urine. Yang ni main job of nephron actually. First mesti ada filtration, okay, by glomerulus. Reabsorption, secretion. Okay, kalau you notice dekat sini, filtration function carried out by glomerulus. Okay, ingat balik glomerulus tadi dia macam penapis, filtration. Reabsorption and secretion. Dua ni kita boleh combine. Reabsorption and secretion. Function ni carried out by tubule tadi. Apa jenis tubule tadi? You have two types. Proximal convoluted tubule and distal tubule. Okay, so both proximal and convoluted involve with reabsorption and secretion. Reabsorption maksudnya you want to reclaim whatever valuable solute. Apa-apa yang penting, important for your body, you kena reabsorb balik. Maksud reabsorb tadi, dia akan masuk balik ke dalam your blood capillaries. Okay, dia akan masuk dalam your blood capillaries, yang peritubular capillaries tadi. Secretion maksudnya whatever yang berbahaya, for example toxin, whatever apa ni yang kita tak perlukan from our body, dia akan remove. Macam mana? So daripada blood capillaries, boleh imagine balik daripada blood capillaries kat sini, dia akan masuk ke dalam proximal tubule. Okay, so kita akan secrete dia. Okay, masuk balik ke dalam filtrate. Okay, the term filtrate ni bila kita akan guna term filtrate ni bila dia dah berada dalam proximal tubule ni. Okay, starting from glomerulus, dia akan release filtrate. So whatever yang ada dalam ni, yang kuning semua ni, kita akan panggil dia filtrate. Okay, so your kidney will remove metabolic waste, okay, such as urea, creatinine, uric acid, okay, and excrete them in the form of urine. That's why bau, kan, bau dia agak ni lah sebab bau urea dekat situ. Okay. Okay, next. Kelas gambar ni tak ada, tapi saya nak highlight function nephron dekat sini. Okay, saya siap buat ni sebab kita punya nota ada 3 je. Okay, ni saya dah mention tadi, this is where blood enter from renal artery to afferent arteriole. Okay, and bila dia sampai dekat sini, okay, you nampak tak? Dia akan filter the blood. Okay, glomerulus will filter the blood. Glomerulus capillaries, because it is blood capillaries. Okay, so kita panggil the glomerular capillary will filter the blood. So siapa yang receive? Bowman capsule will receive. That's why first function adalah filtration. Okay, then you tengok kat sini peritubular capillaries kan. So dekat sini you ada filtrate. Mungkin inside this filtrate you have valuable solute that your body need. For example, amino acid, vitamin, calcium. So apa yang terjadi? Reabsorption. Reabsorption maksud dia nampak macam keluar, tapi sebenarnya reabsorption dia akan masuk to our peritubular capillaries. back to renal vein, back to heart. Okay. Okay, so ni kita nak reclaim balik yang penting-penting tadi. Important solid. And what happened here? Maybe in this blood capillaries, you have toxin in your body. So you want to remove those toxin. Okay, nitrogenous waste you tak nak. So dia akan kat sini secrete. So now you ada secretion dekat sini. So dia akan secrete, okay, toxin. And last kali to collecting dark and dia akan expel out. Okay, in the form of urine. So now you dah patut faham that your nephron function in filtration, reabsorption and secretion. Filtration by glomerulus, reabsorption and secretion by tubule, distal tubule and proximal convoluted tubule. Jelas semua? Jelas?
Jelas.
Okay, so gambar ni you tak ada tapi saya suka guna gambar ni, senang nak explain. Yang ni yang gambar yang you ada. So dekat sini pun you dah conclude dah. Glomerulus filtration, okay. And then number 2, you have proximal tubule, right? Nampak tak functional? Reabsorption and secretion. Okay, number 3, you have what? Distal tubule dekat sini kan? Sama juga. Reabsorption and secretion. Okay, yang keempat ni tak ada. Tadi dia bagi 3 je function. Cuma dekat sini what happen in collecting dark, okay, reabsorption of more water and urine become concentrated. Ni dalam keadaan your body lacks water, so you nak conserve balik, so dia akan nampak macam keluar tapi kita panggil dia reabsorb. Okay, water will be reabsorbed. Kalau banyak dan dia akan keluar. Okay. Okay, next. Dia nak perkenalkan apa ni kat sini. Okay, now tadi glomerulus, okay. So Bowman capsule, okay, it surrounds the glomerulus. Okay, so urine formation begin here. Blood flows through the glomerulus capillaries under high pressure. Okay, maybe when you read from textbook, any textbook, you akan jumpa pressure. Dia akan macam ni tau. Hydrostatic pressure, osmotic pressure, blood pressure. Tak kisahlah whatever pressure, dia merujuk pada darah actually, yang very high pressure from renal artery. Daripada heart to renal artery to afferent arteriole is under high pressure. Okay, and force more than 10% of the plasma out of the capillaries into Bowman's capsule. Maksudnya 10% of the plasma in your glomerulus will be pushed out of the capillaries, masuk ke dalam Bowman capsule tadi. Okay, Bowman capsule ni dia macam ada space tau. Dia capsule yang surrounds glomerulus and bahagian tengah dia is like macam ada space dekat situ. So plasma akan masuk daripada capillaries to the Bowman's space. Okay, so filtration occurs as high blood pressure. Ini saya mention tadi, high blood pressure, high hydrostatic pressure forces fluid from the blood, okay, in the glomerulus into the lumen of Bowman capsule. Lumen ni space lah, into the lumen of Bowman's capsule. Okay. Now, hydrostatic blood pressure in the glomerulus capillary is higher than in other capillaries. Tak kisahlah in other capillaries, tapi nak cakap yang hydrostatic blood pressure in the glomerulus capillaries is very high. Okay, it's very high. Titik, cukup. Okay. Kenapa? Due to high resistance to outflow presented by the efferent arteriole, which is smaller in diameter than afferent arteriole. Dekat sini kalau soalan tanya kenapa high hydrostatic blood pressure class, so you buat macam ni, afferent diameter is okay bigger than efferent. Ni reason dia. Okay, kenapa high blood pressure? Because of okay afferent punya diameter okay is bigger than efferent arteriole. Yang ni yang menyebabkan high hydrostatic blood pressure. It's like macam, saya tak tahu fizik ada hukum dia tak? Hukum apa-apa. Feel like daripada besar kepada kecil. It's like macam dia, macam, apa ni? Ada hukum tak? Bernoulli ke? Saya tak pasti apa hukum dalam
Ada.
fizik. Ada kan? Itu yang berlaku daripada besar diameter kepada kecil. So, blood pressure, okay, menyebabkan high blood pressure. Okay, so menyebabkan berlakunya filtration. Apa lagi? Large surface area for filtration provided by the highly coiled glomerulus capillaries. So you have ball of capillaries kan? So it provide large surface area for the filtration. And last kali, great permeability of glomerulus capillaries. Kenapa dia great permeability? Okay, maksud great permeability tu sebab dia ada pore. Because due to numerous small pores between endothelial cells, okay, make the glomerule more porous. Dia nak cakap sebenarnya you punya, okay, kalau you boleh lukis you punya blood capillaries, okay, sebenarnya your blood capillaries ni dia macam dia punya structure dia tak apa ni, macam ada gap tau kat sini, ada gap. Okay, ni gap, dia porous, ada gap, ni ada gap, ni ada gap, faham tak? Your capillaries ni is made of endothelial cell. Endothelial cell ni memang nipis, about one cell thick sahaja. Okay, one cell thick, nipis. And dia ada pore dekat sini sebab dia tak rapat, dia ada pore. Okay, small pores between endothelial cell. So bila dia ada pore dekat sini, dia porous tau. Porous maksudnya boleh ditembusi, ada liang dekat situ. So whatever inside these capillaries, okay, whatever yang masuk dalam ni, dia bila ada high blood pressure, dia boleh terkeluar. Apa-apa yang ada dalam dia boleh keluar. So that's why bila dia masuk dalam glomerulus ni, blood, okay, dia ada mention 10% of the blood plasma ni, dia akan keluar. Okay, because of porous tadi. Okay, because numerous pore dekat sini. Okay, so numerous pore kat sini kita panggil dia porous. Okay, itu maksud dia. So that's why dia permeable. Okay, ni semua factors lah. Okay, that contribute to production of glomerulus filtrate. Okay, now blood is carried by an afferent arteriole to glomerulus. Ni you dah tahu dah. Okay, and the blood is filtered as the blood pressure forces fluid through the porous capillaries wall and filtration slits. Okay, ni mungkin perkataan ni susah nak faham. Now, yang ni I'm sure you dah faham. The blood is filtered, okay, as the blood pressure forces fluid, okay, through the porous capillaries wall. Porous tadi you dah boleh imagine, dia porous because dia ada banyak pore dekat sini, because it is made of endothelial cell. Dia tak rapat susunan, dia ada pore dekat situ. Okay, tapi what is filtration slit pula kelas? Apa filtration slit? Dia tak ada gambar dekat sini. Saya rasa ni saya letak gambar lain untuk bantu saya. Okay, so basically kita tengok gambarnya. This is your, nampak tak? This is Bowman capsule. This is your capillaries. Okay, glomerulus. Okay, now dia besarkan bahagian ni yang kotak ni, dia besarkan ni yang you nampakkan. So your capillaries here. This is capillary, capillary, capillary. Yang merah ni endothelial cell. Merah ni nampak tak? Dia panggil satu plasm. Okay, tak apa. Imagine, okay, ada endothelial cell dekat sini. Okay, boleh bayang tak? Ni cross section of your blood capillaries Okay, cross section of your blood capillaries. Okay, so you akan nampak, kita tengok satu blood capillaries dekat sini. So your blood capillaries is actually made of endothelial cell. So ada liang dekat sini kan? Ada liang, numerous pore dekat sini. That's why bila you receive blood, okay, high blood pressure, dia akan terkeluar juga some of the blood plasma because of dia ada pore, okay, and high blood pressure. Okay, lagi satu kelas, boleh tak you imagine, okay, ni blood capillaries you tadi, endothelial cell. Okay, mungkin tak boleh imagine. Okay, can you imagine ada membrane selaput yang surround these capillaries? Boleh tak you imagine? Ada selaput lagi. So it is made of endothelial cell and at the same time ada membrane selaput. Okay, kita panggil dia basement membrane, glomerular basement membrane. Okay, and dekat membrane ni pula dia ada satu lagi cell. Another cell ya kelas, another cell, kita panggil dia podocyte cell. Okay, podocyte. Ni podocyte, 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 podocyte. This is podocyte. This is podocyte. Okay, podocyte. Ni another gambar saya buat ya. This is endothelium cell. Okay, and nampak tak ada gap? Which is your pore kat sini. This is pore. Okay, and this is the basement membrane. Okay, membrane, another selaput that surround your capillaries. And dekat sini you have podocyte. Gambar dia dekat sini. Podocyte, 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 podocyte. Cell, another cell named podocyte. Epithelial cell actually. Okay, keduduk dia kan kalau you tengok dia, okay, dia tak rapat tau. Dia ada ruang. Ruang ni gap antara podocyte ni kita panggil filtration slit. Okay, filtration slit. So you just imagine dekat sini your blood plasma, okay, your blood plasma high hydrostatic pressure dekat sini. So dia akan push blood plasma out of this ni pore, membrane and filtration slit. Ni macam penapis lah, kiranya filter. So, nampak tak? Dia dah filter. So, bukan semua yang boleh melepasi filter ni. Hanya apa? Water, glucose, apa lagi? Amino acid, maybe you ada sodium, potassium. Ni semua yang boleh keluar from this capillaries. Okay? So, macam kalau blood cell, okay, blood cell tak boleh. Protein, tak boleh. So that's why if you have blood cell or protein in your urine, meaning that something macam something lah, ada something yang berlaku pada you punya kidney, because your kidney fail to filter blood cells and protein, because protein and blood cell dia tak boleh keluar from these capillaries. So kalau ada blood cell, maybe you ada infection ke, maybe you ada pendarahan dekat dalam ke, I don't know. Okay, itu macam-macam masalah. Okay, so detected by your urine actually. Kalau ada protein, memang ada problem lah. Okay, so ni masuk filtration slit, gap between podocyte cell. So basically your capillaries is made of endothelial cell. Okay, it's made of endothelial cell, and there is a membrane surround these capillaries known as glomerular basement membrane. And at this glomerular basement membrane ni ada podocyte that makes this filtration slit. So maksud ayat dia ini saya terangkan yang ni jadi panjang je. Takut you hafal dan you tak faham. Faham tak?
Madam?
Ya.
Kiranya yang tadi tu, yang bahan-bahan yang dia keluar macam water apa semua, dia keluar tu masuk yang Bowman tu lah?
Yes. Sebab your capillaries kan dalam glomerulus kan surrounded by Bowman's kan. Cerita saya tadi blood capillaries dalam glomerulus ni, because glomerulus is a ball of capillaries. So bila dia keluar daripada capillaries, dia masuk dekat Bowman's lumen. Ada lumen dekat sini, ada space dalam Bowman capsule tu. Okay? Faham right? Okay. And filtration slit. So now you faham sepatutnya. The blood is filtered as the blood pressure forces through it through the porous capillaries, wall and filtration slits. Okay. Porous refers to endothelial cell tadi yang ada pore dia. Filtration slit because of podocyte tadi. Dia ada buat a gap dekat situ. Okay. So it's like filter. So glomerular capillaries permeable to water. Dia pernah keluar exam 2-3 kali. Dia tanya apa yang boleh penetrate glomerular tu. So water, small dissolved molecule, example salts, glucose, amino acid, vitamins, urea, nitrogenous space. Ni semua yang boleh keluar. Yang tak boleh yang saya cakap ni, your blood cells, plasma protein. Ini semua tak boleh. So make sure you faham and you tahu. Okay, pernah keluar exam. So filtrate move out into an efferent arteriole. Okay, some akan pergi dekat Bowman's. Okay, Bowman's. Ada juga yang masuk dekat efferent arteriole. Okay, so ada dua lah. Filtrate move out into Bowman capsule, and ada juga yang masuk tu efferent arteriole. Okay, yang ni gambar ni. Okay, so hopefully you faham lah. Okay, yang ni tak ada ni saya saja letak. Okay, yang apa your punya capillaries tadi, glomerulus tadi, dia ada endothelium tadi kan, yang pore tadi, and then large pores, and then dia ada basement membrane tadi, okay, membrane yang surrounds your capillaries, and dia ada tadi podocyte cell tadi. Okay, podocyte is epithelial cell sebenarnya. Okay, podocyte, and this podocyte attached to basement membrane, and dia akan leave slits between them known as filtration slit. Ni dah, so dia act as a final filtration barrier. Before it enters the glomerular space or glomerular lumen. Ni tak ada nota ni, saya just tambah je. You tak perlu ni pun. Okay, just untuk saya explain saja. Okay, ni gambar yang you ada kan? So that's why gambar ni saya tak reti nak explain macam mana. Saya tak boleh nak imagine sangat. Okay. Ni gambar yang you ada lah. Okay. Ni pun gambar yang you ada kot. You ada kan? Dekat sini dia ada explain. Side. Okay, the wall of Bowman capsule contact with capillaries. Okay. Tapi bagi saya, podocyte tadi, kalau you nak faham macam saya cakap tadi, gambar saya lebih faham. You have capillary, you have glomerular basement, you have podocyte, epithelial cell tadi attached to basement membrane, produce filtration slit. Okay, gambar ni lebih mudah nak faham compare dengan ayat yang ada ni. Okay, nampak ni. Filtration slit process of adjacent podocyte are separated by narrow gap. Okay. Berapa dah? 937. Okay, yang ni saya masuk kelas nanti, saya tak explain lagi yang ni. Ni proses dia, macam mana filtration tu berlaku, and before kita stop, saya nak tunjuk you dekat video. Video sekejap Video berkaitan dengan glomerular filtration. Sekejap ya. Bagi tahu saya kalau you nampak ataupun you dengar tak nampak pun bagi tahu. Boleh nampak tak? Boleh nampak dan boleh dengar tak?
Tak. Tak nampak.
Tak. Okey. Oh, okey. Try lagi. 2 minit je video ni. Okay. To conclude saya punya lecture tadi. Okay. Nampak tak? Dengar tak? Dengar?
Glomerular filtration.
Dengar. Dengar.
Okay, sekejap. Saya besarkan.
Glomerular filtration. Kidneys are bean-shaped organs which filters blood. It removes waste substances from the blood and regulates water and electrolyte concentrations within the body fluids. The end product of this function is urine, which is excreted outside of the body through urethra, containing wastes, excess water, and excess electrolytes. Urine formation involves glomerular filtration, tubular reabsorption, and tubular secretion. The nephron is kidney's functional unit. At the beginning of the nephron, the glomerulus is a network, tuft of capillaries that performs the first step of filtering the blood. The glomerulus is encased in thin, double-walled capsules called Bowman's capsule. The space inside the capsule and surrounding the glomerulus is called Bowman's space. As the blood travels through these capillaries of glomerulus, filtration causes a lot of plasma contents to spill out into Bowman's space through the glomerular filtration membrane. It consists of 3 layers of capillary valve: endothelium, basement membrane, and epithelial podocytes. This membrane allows some particles of blood to pass through, but not all. The fluid that is filtrate from the capillary blood into Bowman's space is called filtrate and forms the primary urine.
Kelas, nampak tak yang dekat last slide yang tertutup tadi? Ada, you nampak tak blood capillaries, ada blood kan? And then you nampak tak endothelium? Sekejap. Okay, ada endothelium cell, ada membrane, basement membrane, and dekat luar dia ada podocyte yang you tak dapat sangat podocyte tu. Clear tak gambar tu? Daripada video tu. Now you boleh imagine tak? It's like macam ada 3 layers dekat situ in your capillaries. Endothelium cell, basement membrane, and podocyte. Yang ketiga-tiganya menyebabkan berlakunya filtration. High blood pressure and filtration occur. So whatever keluar from that capillaries, dia akan masuk dalam Bowman capsule or Bowman's lumen. Faham
Faham?
Okay. So kalau faham, saya rasa sampai sini je. So nanti pukul 3 saya ganti. Semua okey
Okey dah.
Okay.
Okay, thank you semua. Assalamualaikum.
Okey, madam.
Thank you, madam.
Okey, madam.
Selamat malam.
Thank you, madam.